Hi, welcome to Dissolve Chemistry. Let us continue our discussion on this thermodynamics. So let us discuss regarding spontaneous and non-spontaneous process. Okay, so we'll take several examples and then we will define these two terms, and later we will see the limitations of this first law of thermodynamics. Okay, so what do you mean by this spontaneous process? Okay, any process which is going to happen on its own without any external aid or support of energy, work, whatever it is. So such processes we call it as what? Spontaneous, which occurs on its own without any external aid. Naturally it is going to happen. Okay, say for example, I will take some physical processes, we will take along with that some even chemical reactions also we will see that which are going to occur spontaneously without any external aid or support. It happens to be on its own. Okay, so we'll see that one. First we will take a very simple example. A cup of hot tea kept at room temperature, it gets cooled without any external aid. Okay, and hence we call it as what? It is a spontaneous process. Okay. Similarly, you take a ice cube. Okay, so you bring out from the refrigerator and if you keep it on the table, so then what happens after few minutes? So it is going to convert into liquid water or it is going to fuse. Okay. So if you have gone through any waterfalls, then you might have observed that water is falling from top of the hill to the down. Okay, and what is that? It is going to happen on its own. Okay, or you might have experienced. So if you are going on a bicycle and if there is a slope, so then what you will observe? You no need to paddle. Okay, so it will move on its own. Okay, and even sometimes what happens if the slope is too steep? So then what happens? So you have to apply the brakes to control the speed you have. You might have noticed that. Okay, so all these phenomenons, what we call, okay, so are called as a spontaneous process, and we will see some reactions also. Okay, say for example, you take your LPG gas. If you just ignite it, your LPG gas contains C4H10. Butane is the major component of your LPG gas. Suppose you just ignite this, you give one small spark to that, then what happens? It will burn on its own. Okay, and it will give tremendous amount of heat energy. Okay, right? 9 molecules of oxygen. So therefore you will get tremendous amount of heat energy where delta H is negative for this reaction. Okay, and this reaction, okay, you are not doing any work on that. So just if you give one spark, then it burns on its own. So therefore it is a spontaneous reaction. Another example, I will take a very interesting example that you take water and you throw a small piece of sodium metal. Okay, not large piece, then it may cause, okay, it is an explosive reaction. So therefore you take very small piece of a sodium metal and if you throw it on the surface of the water, you will observe that it skates on the water with burning, and there is an evolution of hydrogen gas and heat energy, and this occurs naturally, spontaneous we can call. Okay, without any external, just you bring the contact, then what happens? It burns, it skates on the surface of the water with the evolution of hydrogen gas, and immediately it will form Na plus and OH minus aqueous in the water, and you will be getting alkaline solution. Is it clear? So like many reactions we find, okay, which occur spontaneously without any external aid on its own, and all such processes are called as what? Spontaneous processes. Okay, so let us write the definition. The process which occurs naturally on its own or without any external aid are called spontaneous processes. Okay, already I have given several examples. Next, non-spontaneous means what? Right. The same tea what you have brought in a cup, hot tea. Okay. So is it possible for that to absorb the heat energy from the cool room and it will get hot? Okay, it's not possible. While preparing tea, where what you have to do? You have to give the heat energy to prepare the tea. So therefore it is non-spontaneous. Okay, means any process, or we will take all those examples what we have discussed. Okay, reverse of that will be what? Reverse of that will be non-spontaneous. How it is? Say for example, you are moving in the slope. Okay, so there you no need to pedal. So therefore, with the free energy, you will be moving. No need to put any work or effort. Similarly, when you travel back on the same road, okay, so you have to apply an extra energy to overcome the ride. Okay, so therefore, or if you want to make, suppose for example, you take from the overhead tank in your house, what you will do? Just if you open the tap, you will get the water. Okay, it is a spontaneous. From the overhead tank, water will come on its own. No need to do any external work, means no need to apply an electrical pump to pull that water. Right? Fill that tank, overhead tank. Okay, what you have to do? You have to apply an energy, or you have to do the work to lift the water to the top of your overhead tank, right? So therefore, so this lifting of water into the overhead tank is what? Non-spontaneous, means you need some external what? Aid or support to bring that particular process. So therefore, those are called non-spontaneous processes. Okay. So therefore, how we define this? The process which can occur only with the help of external aid is called non-spontaneous process. Okay, non-spontaneous process. Okay, and one thing you should remember, spontaneous processes are irreversible, means you can't reverse it. Okay, or if you want to reverse it, it will not be spontaneous, it will be non-spontaneous. Are you getting my point? Okay, so these are irreversible processes, whereas your non-spontaneous processes are reversible. We can reverse it. Okay, should remember this important point. Okay, so this is all about spontaneous process. Okay, so the next question arises: why do these spontaneous processes occur in a particular direction? Okay, so why it occurs? Say for example, right? You take a hot cup of tea. Why it loses energy to the room? Okay. Similarly, why can't I take back the heat energy or to make the tea hot by taking the energy from the room? It's direction of flow of heat energy. Say for example, we have taken cup of tea, right? So heat will flow from hot cup to the room. That is your surrounding room. Here it is surrounding, whereas hot and this is cool. Fine. Okay, heat is flowing in this direction. Why can't I make this tea when it is cooled? So I want to make it hot, but it is not possible to absorb the energy from the room, and I can make it hot. And this is what is not being said by your first law of thermodynamics. That is the limitations of first law of thermodynamics. So what is first law of thermodynamics? We define that in various ways. So we will take one or two definition and we will see that what type of limitations it has. Okay. So that is energy is being conserved. Okay. What is the meaning of that? If the energy in one form, if it is disappearing, it is appearing in another form. Okay. See that one. Okay. Now suppose heat energy. Okay. So if you give the heat energy to the closed system where say for example it contains gas. Now suppose you are giving heat energy. So therefore what happens? All that heat energy is being absorbed by the system and that all converts into its internal energy and it will be stored as a internal energy. Okay. Now suppose you are doing work. Okay. So now if you are doing work on this system, then what happens? It will lead to increase in the internal energy, or if it can lose this energy, if it is diathermic wall, it will lose that energy in the form of heat to the surrounding. Means what happens? Energy will transfer one form to the other form. Energy will be transferred, but we are not going to create that energy. Okay. Neither we can create nor destroy. Only thing is we are transferring that energy from one form to the other form. Fine. So the energy is going to be conserved, but the direction of the process we cannot find that one. Okay. Why the energy flows in a particular direction, it is not being set. According to this first law of thermodynamics, I should draw energy from anything. Like for example, you can take, if I keep, okay, I want to prepare a tea and you take all the ingredients and keep it on the ice. Can I do that tea? Is it possible to draw the energy from the ice? Why it is not possible? It should be possible according to first law of thermodynamics. But it's not possible to draw the energy from the ice, okay, to boil the water or to make a tea. Okay, so energy is conserved. I'm saying energy should flow from ice to the what? Your a container where we are supposed to prepare tea. Right? It's not possible, right? Then why it is not so? The direction of the flow of energy is always in a particular direction. Okay, and that particular direction, it is not being addressed by the first law of thermodynamics. Means the spontaneous processes are feasible in a particular direction or occurs in a particular direction, but that spontaneity or that feasibility, it is not being addressed by your first law of thermodynamics. And to address that one or to tell the direction of the spontaneity or feasibility of the reaction in a particular direction, so second law was being enunciated. It will tell you or it gives the information regarding only the transformation of energy during the process. Okay, but what it will not restrict the direction of the process. Okay, so why it occurs in a particular direction, it will not restrict that. Okay, any process, the transformation of energy, how it takes place, only it will speak about that, but it will not talk about the direction of the process. If the process is occurring spontaneously, means so why it is occurring in a particular direction. Okay, say for example, so if I keep ice at room temperature, it melts. Okay, if I keep the ice at room temperature, it will melt. But now if you want to convert that water into ice, again I have to take the help of a refrigerator where electrical energy I have to use to convert that into ice. Okay, why it so happens? Okay, that we cannot explain with the first law of thermodynamics. Okay, so therefore overall the flow of energy, okay, or feasibility of the process, it is not being addressed by the first law of thermodynamics, and it is important limitations of that. And to overcome that, so we are going to very soon we will define second law of thermodynamics. Then prior to that, still more aspects are there that we will discuss. Now let us fix the criteria for spontaneity of the reaction. if the reactions or the processes are occurring spontaneously on its own without any external aid in a particular direction, means what are the criteria it requires to be spontaneous, that we will see. Okay, criteria for spontaneity. Okay, so we will consider first as energy criteria. Okay, first thing we will see energy criteria and then we will explain. So it was thought that, okay, the processes where the energy of the system decreases, generally what we call, anything is said to be stable when it is at lower energy. Okay, so therefore the process will occur in such a way that if the system is at higher energy, always it tends to move to lower energy. So during which what happens, it will lose its energy. Okay, therefore it was thought that all exothermic processes, okay, so where energy is being lost, exothermic processes are considered, okay, exothermic processes are only the spontaneous processes. Say for example, I have seen what examples we have discussed previously, so that only we will take. So for example, we have taken burning of the fuel, combustion. So there what happens, the energy which is stored in the form of chemical energy, so that is being upon combustion, what happens, converted to heat energy and it is given out, and it forms a stable, still more stable components, that is carbon dioxide and water. Okay, similarly you take a sodium metal burns on the surface of the water. So there what happens, sodium metal in the form of metal, when it is in contact with water, it is unstable, so therefore it will react and energy is liberated and it forms a stable NaOH solution. Okay, okay, so it was thought that energy criteria is the important criteria for the spontaneity of the process. Okay, so is it the only one criteria that satisfies, or it is going to be decide the factor that is either process to be spontaneous or non-spontaneous? No, because you see here, evaporation of water. What do you mean by evaporation of water? Okay, evaporation happens at all temperatures. You should remember this. Okay, even if you keep the water at room temperature, so by the environmental factors, what happens, it will evaporate on its own. Means naturally, means spontaneously, water is going to evaporate. Evaporation and vaporization are the two different things. You should remember that. Evaporation means it can happen at any temperature, okay, and it will happen spontaneously. And vaporization is always going to happen at its boiling temperature or boiling point, what we call. Okay, you should make note of that. So evaporation of water. Okay, so if you take a water from, see for example, you know that one, how we get the rain. We say that you might have studied water cycle. So there you might have studied the water evaporates from the water bodies like a river, pond, or you can take sea water. Okay, it will get evaporated. Or we are maintaining the temperature 100 degrees Celsius? No, but still it is evaporating. It happens naturally, spontaneously. So therefore, evaporation is what type of process it is? Evaporation is an endothermic process, but it is still spontaneous. Okay. Even though it is what? Endothermic, still it is spontaneous. So therefore, what we have considered as energy criteria, it fails or not? Okay, it cannot explain here, right? Take melting of glaciers. Okay, you can take, means global warming leads to what? Melting of the glaciers and leading to increase in the sea level, you might have heard. Is it going to happen naturally or not? It will happen. So therefore it is also spontaneous process. And melting of ice, it happens due to increase in the temperature, you said. Meaning is what? So it is an endothermic process. So therefore melting of glaciers, it is also endothermic process. Okay, but still it is feasible, or it is going to happen on its own. Now energy criteria is not the single criteria that can explain the spontaneity of the process. Then what else is there that makes the process to be spontaneous in a particular direction and non-spontaneous in the reverse direction? Okay, I said it is irreversible. If you want to make it reverse, then you have to do the work, or you have to apply the energy, or you have to give the external aid for to bring that one. Okay, so that next criteria, that we call it as entropy, that we will see in the next video. Okay, till then, bye, take care, and don't forget to subscribe our channel. Thank you for watching.